you're up.
Okay, thanks very much. So I am having some fun here. Very happy to be in São Paulo and to give you this talk. And I've given you some slides in Portuguese, just in case anyone needs a little help with my English. So I am one of the founders of the open source movement in software, but I'm not the first, and I'm not the only one. I announced open source to the world, and that was in 1998. But of course, in my work on open source, we're standing on the shoulders of Richard Stallman and the free software movement. And open source and free software are two different ways to market the same thing to different kinds of people. So the reason that we have open source, especially in English, is because free in English has two different meanings: freedom and no charge. And when you say free to people, it very often means no charge to them, and they don't really think of freedom at all. In Latin American countries, we have Livre software, so that makes a lot more sense. And Richard Stallman, going back to the middle 1980s, founded the free software movement. However, Richard, because of his personal orientation, is much better for evangelizing to programmers than he is to evangelize to business people. And these words free were not very good for evangelizing to business people. So in 1998, a group of people sat down and said, we need to sell free software to business, and how are we going to do it? And so it was decided to call it open source and to market it in a different way with different evangelists. And unfortunately, for a time, this was sort of set against the free software movement instead of working with it, which I was very, very unhappy about. But all of that is over now. I'm the creator of some interesting software. BusyBox is probably in your phone if you have an Android phone. It is probably in your wireless access point and in many other devices, millions of devices in people's homes. And the interesting thing about all of this software, Linux, BusyBox, open source in general, is that it is a part of everyone's life, and most people are not even aware that it's there. For example, in the United States, we actually use Linux systems to display the aircraft and air traffic control. And when you fly, part of your safety is being handled by a Linux system, and so a part of everyone's life. BusyBox is also very well known because there have been lawsuits over it. What happened is some of the subsequent developers to me and the Software Freedom Conservancy have sued 2 or 3 dozen companies who were infringing on open source software. They had violated the GPL license on Linux. And at the time, we didn't have the copyright holders of Linux working with the Software Freedom Conservancy, but we had the copyright holders, at least some of the copyright holders of BusyBox working with the Software Freedom Conservancy. So we sued a number of manufacturers all over the world regarding BusyBox and essentially forced them to come into compliance with the GPL. And that led to companies throwing up their hands and, complaining because they thought a free gift should be a gift with no charge rather than a gift with freedom. And Eventually, we got business educated into the need to comply with the GPL license. And I was entertained, as I often am, to have this camera, which I just bought. And in the camera, it comes with a number of disclosures of the open source licenses used in the camera. The camera has Linux in it, it has Android in it. And so there's the zlib license and the Linux license. I didn't see BusyBox. I don't know if it's there. But it was nice to see that a company like Sony is complying with the GPL license. And indeed, if you go to, I believe, opensource.sony.com, you can see the GPL downloads for all of the various television sets and other products that have Linux and open source in them. And I was the second leader of the Debian project. And Debian is a Linux distribution, and it has derivatives, which are Ubuntu and Mint. And those are the more popular ones. There are some dozen derivatives of Debian in all. And Debian was really the first practical Linux distribution. There were seven or eight before that, but they didn't have community development, etc. They didn't, for the most part, hold up. I actually installed SLS before Debian, and I believe that SLS is still around, although it has obviously a rather rarefied user community. And I'm a filmmaker. I went to college for communication arts, not for engineering, and I'm credited on 2 films of Pixar's. I worked at Pixar for 12 years in all and 19 years in total in the film industry. So I'm credited on Toy Story 2 and A Bug's Life. And also I am a book editor. I have a series called Bruce Perens Open Source Series, which is 24 technical books, and these are with Prentice Hall publishers. And although the books are under open source licenses, the series met the publisher's usual financial goals, and only 1 book out of 24 lost money. So you can actually download the PDFs for these books. They're free software, but people still like the paper versions, and they bought them. And I'm featured in some films myself. One is called Revolution OS, about some of the early days of open source in a company called VA Linux Systems, and a film called The Codebreakers. So I represented open source at the United Nations World Summit on the Information Society, which was a very interesting meeting of the United Nations in Tunisia in the world's biggest tent, a tent about the size of a baseball stadium. And the United Nations Development Program invited me, and this speech is actually being funded by UNESCO. So thank you, United Nations. I founded No Code International. So if you are a amateur radio operator, we call them radio hams, or if you know some, these are people who use long-distance two-way radios on the air, and some of them build their own radios and get to learn a lot of wireless technology hands-on in a way that you can't really learn without amateur radio. And in the 80s, I felt that we wanted to teach another generation of young people how to operate wireless technology, and that ham radio was an excellent tool for doing that. But there was this barrier of entry, which was that you had to learn how to receive and send messages in Morse code, like a telegrapher from the 1920s. And that was required in the license, and not only did the nations require it, it was a part of international treaty law. So we had to change a treaty requirement of the International Telecommunications Union, which is part of the UN. And after they removed that requirement, approximately 210 countries removed their requirements for Morse code for an amateur radio license. And thus, many people today can get their radio ham license just by knowing some technology, which is the way it should be. And once they have the license, they're free to use Morse code if they like it. And many people still do, but some of us are interested in the more modern aspects of radio. I have two companies, and legal engineering is the one that makes money. Algoram is my startup and does not make money. And legal engineering is a consultancy. So it assists law firms and the law firm's customers with issues of open source and other legal technical issues. And the way it works is that we find that in many companies, the lawyers and the engineers are not very well connected. And the engineers don't really understand why the lawyers are there and view legal things as an impediment in general, which is in part true. But why are lawyers there? Lawyers are there so that we do not resolve our fights with violence, so that we resolve them instead with negotiation in the courts. So I definitely want to work with the lawyers rather than resolving GPL compliance by duking it out with people. So, so legal engineering helps the attorneys, and I have a number of very large public stock companies who are my customers. So that's how I make money. And Algoram produces a software-defined radio transceiver. And we're still working on this. We tried one design and it failed, and we're now on our second design. And the reason for building this software-defined radio transceiver is that we built a lot of very interesting software for radio. You may have heard of GNU Radio, which is a system for making radios essentially on the screen as software rather than hardware. And I worked personally on a digital voice compressor called Codec 2. The main engineer is in Australia, but I was the creator of the project and inspired him to work on it and have done my own software contributions. Codec 2 can compress your voice into 1,200 bits per second, and we get a clear voice signal out of that, and it is entirely open source. And I calculated how much memory I had in my phone, and it turns out that using Codec 2, I can store all of my voice for the entire rest of my life without having to upload it. Because it's that efficient in compression, and it is indeed more efficient than many commercial codecs that are available. But we had trouble getting manufacturers of radios to put the software in their radios, so we decided we would start making radios and be a disruptive technology manufacturer, rather than waiting for the big players to start using our software. So why do companies use open source and open hardware? I'm going to talk very much about the economics of open source software, and almost everything that I'm talking about also applies to open source hardware. Now, you'll notice I say open hardware. I don't say open source hardware. Why do I do that? Well, there was someone who made up this acronym, Free Libre Open Source Software, which is the letters FLOSS, and floss in English is something you use to clean your teeth. And at that point, I decided that we should use short algorithms instead. So it's open hardware. So why do companies use open source and open hardware? Well, the number one reason is not cost. It is control. So if you are a business person, the very worst thing that can happen to you is have aspects of your business that are out of your control. For example, say that you make gate array software. I've had customers who are commercial producers of gate array software. And they found that the gate array foundries, the silicon foundries, were a barrier of entry. And they used open source, even though their main product is proprietary, to create an API layer which interfaces to all of the silicon foundries that make integrated circuits. So once people use this API, all of the foundries look the same. Their differences are submerged in the API. And thus software that was not compatible with certain silicon foundries suddenly became compatible once they built in this API. And my customer gave this API to their very worst competitors as open source. And the reason that they did that was they wanted to take a part of their business that they did not control, the silicon foundries, and commoditize it. So that instead of competing on different APIs and lock into their own API, the foundries would have to compete on cost and efficiency. And this was a beneficial business decision to my customer because they sold software for working with VHDL, a silicon programming language. They did not operate the foundries. So that's control, where you use open source software to take a part of your business that you formerly did not control and get control over it. Or to control aspects of your own business where you own the software that you're using and you can modify that software as you desire. You don't have to convince a manufacturer that the feature you want is desirable. I remember working at Pixar where, of course, I didn't mostly use open source. It was long enough ago. I spent many a day on the phone and email to manufacturers trying to convince them to do something, trying to convince them to fix a bug or sometimes to add a feature. Okay, another reason that companies use open source and open hardware. Collaboration in development is an economic thing because it distributes the cost and risk across many companies. So say that you get another company to work with you on open source software that's important to both of you. Now, you're not paying for all of the development. They're paying for half of the development. And that gets larger until you get to the point where perhaps 20 or 100 companies are working on development and you all have the benefits of it and no one is making the main investment into it. And the risk that the development does not work out has become less expensive because all of you are sharing that risk and the cost of that risk. So this is an economic factor in that we get to take a cost, which often, with proprietary software that we developed all inside, we bore that entire cost. We had to hire people first, put them to work for a year, and then hope that what they did worked. Okay, where with open source, first of all, we can see what everyone's doing, and we actually have more visibility and more confidence. And then as it is developed, we share the cost and risk across many companies. Another reason is best practices. As I said, I guess I didn't say, I was an executive at Hewlett-Packard. And at Hewlett-Packard, we had software that we sold to large stockbroker companies in the United States. So one of them was Price Waterhouse. And sometimes Price Waterhouse would have what they thought was a bug, and they'd insist that we fixed it, and perhaps the programmer did not see it as a bug and was a little disgruntled by this request. So in the Hewlett-Packard source code was a rather disparaging comment regarding Price Waterhouse. Okay, and when we went to open source the software, we had to find all of these things and take them out. Well, there are a lot of things like this where developers who are working without being watched by a larger community don't do as good quality work as if the whole world is looking over their shoulder in open source. So open source is a best practice where developers are scrutinized, their work is public, and their work actually becomes their resume. Now, your work being your resume is a really important thing. When I had to hire people for Pixar, perhaps that person worked for IBM, I could never say to IBM, please show me some source code written by this person. That would just not work. However, if that person had been a part of an open source project, I could see the work that they had done, and I could also go on the project's mailing lists and see if they had been a good collaborator or if they'd been obnoxious. So open source actually gave me a lot more knowledge about the individual developer that I would use to hire them or not hire them. And of course, the other side of this is that if you know that people are looking at you, you'll behave better. Well, some of us still don't behave, but it works for a lot of us. And then we do get to cost. In the case of software, the cost of the actual software approaches zero. You will have costs such as external or internal support of the software, training, etc. But you won't be paying a royalty for it. And that is important. It becomes even more important when we get to things like the cloud, where companies try to license every cloud instance, and no, that doesn't work. And thus, Linux has become the standard platform of the cloud because we don't require that you license every cloud instance. So, the intellectual property rights handling for proprietary software. For example, have you ever had to work with a license manager? You know, you have this piece of software and you have to give it a cryptographic file before it lets the program run. When you go on the cloud, that just gets to be too much of a pain. The license management breaks and then you're off the internet because of it. And another reason is that the typical capitalist paradigm of developing products does not work for all products. So in the typical capitalist paradigm, we have people who get an investment. Okay, so perhaps they collect $5 or $10 or $15 million, and they hire developers. And they put those developers to work for 5 years, and then when they're done, they sell the software. Well, that means that you have to go out and do a public offering or get a venture capitalist and create great amounts of money, and thus you are financially front-loaded. You have to get the money first, then do all the work, and then at the very end, you may start making the money back, or you may not. Okay, so that's the capitalist paradigm. It only works for a subset of all desirable products. So take, for example, the web browser. The first people who tried to develop a web browser to have an internet were a project called Xanadu, which was formed by Ted Nelson and bought by Autodesk. And Autodesk invested $10 million at the start and more millions during this. And Xanadu had a monetization paradigm for the web, which was that every line of text that you wrote on a web page, you would get paid for. A tiny fraction of a penny, they called them millicents, very small fraction of a dollar. And even derivative works would track this, and you would get paid for your writing all across what they called the Xanadu system. So they had a practical economic monetization scheme for the web, and it was too complicated, and they didn't get it implemented in time. And then Tim Berners-Lee came along and made the Mosaic web browser and the server. And Tim did something that was in some ways economically irresponsible. Tim said, I am not going to provide a way to monetize the web. I am going to allow all of my users to figure out how to make money from the web. And so people started to make websites and to use the web browser, and we had an economic boom of investment in web companies before anyone actually knew how to make money with the web. And then we had a bust as many of these companies collapsed. It created quite a lot of economic struggle. And in the end, we finally, after the death of many companies, figured out how to make money from the web. But Tim did not give us a way going in. And Tim's way was more successful because it was a community way. It was saying, I am going to enable a very large community to have this technology of the web, and I'm going to let them figure out what to do with it. I'll let them figure out how to make money with it. And it was very disruptive, but it was ultimately successful. So no one wanted to pay for Tim's web browser. In fact, it was paid for by CERN. It was public research and his web server as well. And then other people in other companies and communities started making web browsers and servers that interoperated with his. And, we get to the present day where we have Chrome and Opera and Firefox, etc., and Apache. So the capitalist paradigm would probably not have supported the development of most of these products, because when people were thinking about making them, there was no market demand for them. Nobody had heard of the web, and nobody in finance had any idea that people would want to have a web. So the development had to proceed as open source. And unlike the capitalist paradigm, open source is not front-loaded. You take one person's work, where one person is not particularly expensive, and that one person puts out a program that probably barely works, and then allows other people to build upon it. And so it's small and incremental investments, often of people's spare time or time that they should be working on other things but aren't, probably in Tim's case. And so this means that you don't need this investment, at least to get started, for many things. So why do companies have software? Okay, number one reason is not to sell it. Okay, it is to support their own operations. So a very small minority of companies that make software actually sell their software. Over 80% of programmers employed today, these are figures for the United States, write software that is not intended for sale. Okay, the majority of software written is never intended to be sold. And that is figures from the United States Department of Commerce, which collects statistics on jobs and employment. So most of the people who work on software are working on software internally, or are working on software that is not meant to be sold. It's meant to be used within their company, perhaps to do one job, enabling a process or a website or a financial activity. Now, how does this connect with hardware? In general, hardware is a tool in a company rather than the main profitable product, just as most software is. Hardware might be a computer or a peripheral, okay, which is used to do some sort of business. It's not the main money maker of the company. It's a tool like a shovel that they have to have and they have to use, but it's economically in what they call a cost center. Okay, and a cost center is where you take all of the things that you have to do to have a business and pay for them, and a profit center is where you take the things that make you money, which are actually a very small part of your business, and those things drive the profit. So, in general, hardware is a tool in a cost center. It's some sort of infrastructure enabling technology rather than the main profitable product. So lots of people are in economic trouble today all over the world. There are people sleeping on the streets. Here in São Paulo, at home where I live in Berkeley, we have about 1,000 homeless in Berkeley and many more in San Francisco. Open source and open hardware seem to make little economic sense at first. Okay, so when I started talking about this, people were sort of looking at it as a high-speed trip to the poorhouse, as a way to go broke, helping other people. And giving away the right to use, copy, and redistribute your software or design. Gee, that doesn't make sense to people who view business entirely as a profit process. But most of the things that happen in business don't drive the profit. They drive the enablement of the business. Obviously, open source has been tremendously successful. And today, millions of profitable businesses are using it. And open hardware is starting this same take-up, where businesses are starting to use open hardware in designs or share open hardware designs among companies as the best way of doing things. So, for example, there's a group of companies that shares a server motherboard design, which is the cheapest way for them to serve massive amounts of web traffic. So, is this driven by some strange, non-intuitive economic principle that makes things work without profit? No. The economics of open source are actually quite conventional. They're just things that people don't see immediately. And there's a company in the States that makes a radio program called Freakonomics. Okay, and Freakonomics is about very strange economics, and I always cringe when I hear this program. So the fact is, none of the economics are actually very strange. They're just things that we weren't using until recently. So can we help people improve their situation here and elsewhere? So, let's see, do I have this right? Does that say the economics of tools? Yes. Good. Open source is a huge toolbox full of programs for teaching, serving web pages, emailing with customers, writing computer programs, designing integrated circuit chips, and thousands of other tasks. And there are two possible economic benefits from tools. The creator of a software tool might benefit from its sale as might retailers and wholesalers. So this is the Microsoft paradigm, for example, where Microsoft develops proprietary software, Windows or Word, and sells it to companies and to individuals, asking for an annual royalty or a license of some sort for each copy. And so they put a lot of money into the development, and they eventually recover it through sales. And people who are naive about the production of software and its economics think, well, this is what you do. You make software and you sell it, and this is the economics of software. Well, it turns out that it isn't, because software is a tool, and billions of people and companies benefit from using the tool. And they can drive millions of businesses by doing so. So which is the larger economic impact? It is the impact of the users rather than the producer. So Microsoft makes lots of money, but billions of people make much more money by using Microsoft software or by using open source. And that is the main economic impact of both Microsoft software and open source software. So we have to start looking at things from the user's perspective rather than the vendor's perspective. We've been much too vendor-centric in considering the economic function of these products. So tool use is the largest economic impact. And tools empower people to do some task they could not do before as well, as easily, or at all. So, you know, your typical tool is a shovel. And a shovel allows you to dig more easily. And if you can dig, you can farm more easily, and you can feed yourself and your family, which you might not be able to do if you did not have that shovel. And thus we see in the museum many farm implements made by people hundreds of years ago here in Brazil to start farming the territory as they migrated to it. And the tools were their empowerment. The task of a tool today is often part of a business that produces income, and there can be millions of such businesses. So the economic impact of using a tool can be much larger than the economic impact of selling a tool. And tools are wealth. So a tool that extends the capabilities of a person is empowerment. Empowerment is wealth. Not wealth that you can eat, but wealth that will allow you to do things that let you eat. Okay? Just as you can eat a shovel, but a shovel will allow you to feed yourself where you might not otherwise. The work you do with a shovel or a software tool may indeed feed your family. When people use open source, they gain useful tools, usually at zero cost. With open hardware, they get designs for good tools that can be produced at low cost. And this gift can never be taken away. The open source licenses grant a perpetual right to use, modify, copy, redistribute, so that anyone can service and extend the software or designs, and new users can always get it. Does that say charity and business both? No? Okay. That's the one. Oh, I missed a slide already. Okay, so our first economic lesson from open source is that the users are the most economically important aspect of tools, and that open source is of benefit to the economy because it produces great tools at the lowest possible cost, zero, or for open hardware, close to zero, and make sure those tools will keep on living. From a user's perspective, the production of open source is a tremendous act of charity by the developers. Isn't it funny, then, that most open source developers aren't developing open source as an act of charity, but as part of operating their business. But how can business people share their software with all of the world's users without going broke? How do you do this and still make money? The fact is that developers are users too. They need the software to do something important for them, like operating part of their business. But unlike the conventional business model, open source developers share in development. Many people in many different companies, universities, also private individuals, work together on one program. And by sharing in development, they distribute the cost and risk of development so that nobody is giving too much and all developers benefit. And look at what they have made, for example, the Linux kernel. What if you tried to do this just as an individual? Well, Linus contributed the first 20,000 lines and would not have been able to make the rest of this without a community. So by finding a community, we are empowered to make things that we otherwise could not. And that's where the internet comes in. We could not have done this without the internet. And in fact, our very first developments on open source were done without the web and without the IP-based internet. We used Usenet. Okay, so software isn't their product. For most of the companies that are engaged in open source development, that particular software isn't their product. For Amazon.com, it's books. For Google, they run an information service and know everything about your life. You know, some of them make farm produce, some of them make automobiles, but all businesses today need software to operate it all. So the open source is infrastructure, it's an enabling technology, it is not their product. And this is, I think, the most important concept in the entire talk, which is business differentiators. Most companies have something about them that's a business differentiator that makes their business look different from that of their competitors. It has to be visible to the customer, and it is a feature that makes that business more desirable to the customer than another one. So for Coca-Cola, the business differentiator is the taste. They have a secret recipe. For Amazon.com, it used to be the recommendation system. Amazon was the first company online which, when you bought a book, would recommend that people who bought this book also bought a second book. And very many times people would see that and would buy that second book. And that actually increased the profit of Amazon more than twice, because all of the cost was in putting the first book in the box and mailing it. And if they could put a second book in that box, they actually made much more profit on the second book than the first one. So for Coca-Cola, they can't share the recipe. For Amazon.com, they could not share the recommendation system, while it was something that Barnes & Noble and other bookstores did not have, because it was their business differentiator. It made them look better to the customer. So it was the one thing in their company that could not be shared with a competitor. Obviously, companies don't share their business differentiators as open source. But can Coke share with Pepsi? Coke can't make their recipe open source without damaging their business. They must protect their business differentiator. But Coca-Cola could share everything they know about operating websites with their competitor Pepsi. And the major effect would be splitting a development cost and lowering the cost and risk of development for each company and reducing expense. So let's take a look at the Coke and Pepsi of the computer business. We have IBM, Dell, and HP Enterprise as development partners on hundreds of open source projects, even though they are competitors. It happens that their customers all want to run these same open source programs on IBM, Dell, and HP Enterprise computers. So how can IBM, Dell, and HP Enterprise share their work on an open source project when they are competitors? Well, it works because the project leadership of an open source project is by technical meritocracy, and the project leadership has no power to force anyone to do anything, only to persuade. So if you are HP and you are partners with IBM, you have your engineers communicate with IBM, not your marketing people, on an open source project. And the engineers can persuade the engineers of IBM that working on a particular feature is interesting, but they can't force them to do it. And it turns out that we get a lot done that way. And this works equally well for open hardware. It turns out that putting the engineers in charge builds a better partnership than having the project directed by marketing or management. The engineers share a common goal of making great software, while marketing and management often contaminate the partnership with their competitive aspirations. So I call this the handshake and the dagger. We used to have a way of companies collaborating which was called the consortium. So you will remember before the advent of open source, we had the X window system developed by the X consortium. This is going back to the 1980s. And one day, the X consortium, which was driven by marketing people who actually paid to be members. The companies in the X consortium had pay for, say, they would put in so many $100,000s of dollars and they would get to direct the project. And so they decided that they would not have any canonical user interface for the X window system, that they would not have one set of user interface elements that was common to the X window system. They wanted to have Sun Microsystems workstations and HP workstations and Apollo workstations. Does anyone remember Apollo? They wanted them to all have their own user interface elements and to have different programming APIs for these elements so that they could lock their users in. There would be a cost to moving from Apollo to HP because you'd have to reprogram all the user interface elements. Well, it turned out that Microsoft was actually a member of the X Windows consortium. And the Microsoft people must have been laughing into their sleeves because while the X Windows consortium decided not to have anything in common, Microsoft went ahead and created a common set of user interface elements which they would sell on HP and Dell computers. Apollo never got in the PC business. And of course Microsoft won because it did not create this false business differentiation, okay? Business differentiators, making your business look better than other businesses, is done by having a unique value, not a unique handicap, okay? And having an extra customer cost of vendor lock-in, of programming a different user interface element when they move to another manufacturer. This is negative business differentiation. It's something the customer sees as a cost and impediment and makes it less likely that they will buy your product. So along comes open source, and the open source projects say, we're going to put the engineers in charge and not have the marketers, with their efforts to win over their competitor, in charge and not have these problems like the user interface decision which sunk X Windows in the market. Jim Geddes, one of the founders of the X Windows system, says that was the very worst day in his entire life, the day they made that decision. So we have something in open source called forking. And it used to be that people saw forking as a very negative element of open source. They didn't want to have the prospect of a project forking and then there'd be two versions and divisiveness and fighting. And actually it turned out that forking was one of the most important elements of open source software. So open source includes this right to make your own version of a project, and that's called forking the project. And it's almost magical in its effect. When you split off a project and take it in a different direction from the original developers without their permission, you can get around any problems that are in management of a project. You can do what you want. And so we should really call this the right to avoid bad management, because that's what it's used for. If other developers like your fork of the project, they will abscond. They will come over to your version, leaving the old version of the project, and work with you, and your version will prosper. And if not, only your work will be wasted, not that of the entire team. And in some cases, all of the developers of a project have forked away from one bad manager. So we had the transition of the X Windows project to from X-Free 86 to X.org. And that project flourished, and the old leader was forgotten. And so that's a meritocracy issue. It's where one particular leader made bad business decisions for the project. The engineers didn't like the idea, and they all said, well, we don't need this person. We'll just take the project and move it elsewhere. And they left that one project leader essentially alone. Now, the other side of forking is that once you've done your thing, once you've done what's different about your fork from the other version of the project, you can put it all back together because you're both using the open source licenses. And the open source licenses don't require a signature for you to unite the efforts of two projects. So we had, for example, the libc development. Libc is the C language library for GCC and, in general, Linux and Unix systems. And when Linux just started up, the libc people were concerned with working on Unix workstations. And Linux was not their main direction. And they weren't very responsive to the Linux developers. And so we forked, not hostilely, in a friendly way. We forked the libc project and made a Linux libc, which was separate from GNU libc. And we went on with development for, about 3 years. And at that point, Linux and the BSD system, I think, were the most important users, and the Unix workstations were actually failing in the market. And at that time, we put the two forks back together. And so now it is again the libc project instead of the Linux libc project. So that was a case where people said no or didn't help us, and because of the power of forking, we were able to get what we wanted done on our own, and there was really no impediment. There's also a Darwinistic process to open source. So good ideas and good leaders develop communities, and their projects expand. People with different ideas of how the project should go can pursue them and build their own communities. And we can put together the results of these separate communities without asking for permission, because the open source licenses give us that right. So people ask me, what is the marketing paradigm of open source? You know, my company has marketing. Does open source have marketing? Do you have a roadmap? Do you have a plan? Do you know where you're going, where you'll be in 5 years? Have you tested your ideas with the consumer? For the most part, the answer is no. It works better if we don't. And the reason that it works better is because there are very many of us. So the marketing paradigm, I'm sorry I didn't translate this to Portuguese. The marketing paradigm of Linux and open source is a massively parallel drunkard's walk filtered by a Darwinistic process. Well, what the heck does that mean? Okay, massively parallel drunkard's walk means that everyone does their own thing with no coordination with anyone else. And Darwinistic process means we filter the results of this and we take the good ideas and build communities around them which prosper. And the bad ideas die on the vine while they are still the work of only one person. So not much money, time, and effort is wasted. And in general, that one person is happy to go on to another project and try again. They don't leave in disillusionment most of the time. Critical to this is the control that open source gives you, because you have the source code and the right to change it and to give others those changes. And this, of course, is all common with open source and open hardware. It's only because you have that right to change and redistribute that you aren't bound to someone else's agenda, even that of an existing open source team. And this also means that you're not locked into a company agenda. So you won't get things that are rampant on proprietary platforms like spyware, or the sort of corporate totalitarianism in which Apple controls what you can get in their app store. So corporate totalitarianism is an interesting phenomenon today. We worry very much about our governments and what they know about us and how they manipulate us and restrict our rights, etc. We might not worry as much about the fact that if you have an Apple phone, that Apple phone mediates all of your communications with the entire world. It has a microphone inside of it that you are never really sure is turned off. Okay? It tracks your location. Okay? How many electronic devices with cameras and microphones do you normally charge in your bedroom? Okay, for me it's a reasonably large number. And I'd hate to think about, people actually could be listening in. I don't, like many people do, they put little Post-its over the TV camera. I don't routinely do that. I don't, in truth, have all that much to hide. But we have today a system that George Orwell could never have imagined when he wrote 1984. Okay? And then we have a company like Apple Computer, and I urge all of you who are rampant open source nuts, okay, if you are a free software only kind of guy, please go to the Apple Store, try to look normal, not like a freak, and just stand in the Apple store and quietly watch how happy and excited everyone is because they feel that these things are liberating tools, that they are not binding themselves to Apple's corporate totalitarianism, and to a degree that is true. Okay, so as open source people, we have to understand what the other side is doing and what the other side has that we do not so far. Okay, so I actually do this regularly. I go to the Apple store and I just look at it and I say, well, what's Apple doing that we aren't? And, you know, can I evangelize for people to do some of these things? And a lot of it is user interface and human factors. And also it sort of takes down my ego. Because, you know, in some ways we are not winning, and I must see that and accept that, and I urge you to do so as well. But the truth is that companies these days have a lot of control over us, and intellectual property is one of the things that they use to control us. If you have a Blu-ray player, or you download and play movies, you essentially have an electronic cop in your living room who makes sure that you only play what a company approves you play. That's digital rights management. Richard Stallman calls it digital restrictions management and thinks it's more accurate to call it that. And yeah, I agree. Digital rights systems essentially restrict people and implement those restrictions in their operation. So in the free software world, we avoid that, and we have to start pushing that more as a social benefit. So we have a new economic paradigm for producing excellent software and starting to be hardware that anyone can use. It's produced very much more than any one company could, no matter how large. Okay, no company could have made the Linux operating system kernel. Think of how many different computers that runs on. Okay, no company has ever made a system that ran on that many different computing architectures. No software of any kind. You know, not even an application, I think. So, although people might not notice it, this stuff is now all around us. It's in our phones, our televisions, our networking equipment. The list just goes on. So now we take this to hardware. So no one can deny the role of Apple in today's world. But let's look at the downside. Okay, I worked for Google on a case called Oracle versus Google. I was a strategic consultant to the outside counsel, which meant that I worked for a law firm that itself worked for Google. And one of the things that I did in that case was I went to surplus stores in Silicon Valley and bought manuals for old computing systems to show that Sun Microsystems had copied APIs to a much greater extent than Google's 7 files in unplanned copying in Android. So if you've been to Silicon Valley, I actually, for work, went to Weird Stuff Warehouse and bought a still poly-wrapped version of Sun's 1980s spreadsheet manual, etc. So in doing this, of course, I'm billing Google's lawyers and I'm creating testimony, which we eventually showed to the court. We showed that Sun had copied VisiCalc. And Dan Bricklin, the creator of VisiCalc, is still around and actually has online a working executable for VisiCalc that you can download. So you can use it as evidence, among other things. So in the year that I worked on Oracle versus Google, both Apple and Google spent more on litigation, lawyers and courts, than they spent on all research and development. Okay? So this is where the proprietary world is going. They are so trained into their tight grip on intellectual property that it is eating them. Okay, that it is more expensive than the actual creation of the intellectual property. And so they put more energy into the fighting than the innovation. And it's a war that none of the combatants can win. The best that we can hope is to keep them from damaging open source by restricting it with software patents and open hardware by patents. And we are actually operating, in my opinion, the last sanctuary for pure innovation in a world of corporate greed. So let's get to open hardware. Open hardware is the design of a physical object or an electronic circuit that is shared under the same terms as open source software. Now, if you were to the talk last night, you may have heard my long talk on why copyright doesn't work for hardware. And that's a complexity that we will either not discuss in this talk or we'll save for the questions. But we try to put hardware under the same terms as our open source licenses. And the objective is to have the same sort of collaboration that occurs with open source software. So we have enabling factors like open source software in Linux. We have enabling factors that make this revolution of open hardware possible. So let's go back to Linux and open source. The enabling factors were the internet. They were frustration with the state of software and an extremely low point of entry to be able to produce software. So to produce software, you need a laptop and GCC, the compiler. Okay, very low cost of entry. You don't have to have a $1 billion research laboratory. And I always smile about $1 billion research laboratory because on the day that I was leaving Pixar, I walked into Steve Jobs' office and I said, Steve knew that I was leaving to work full-time on open source, to be in a business related to open source. And I said to Steve, you still don't buy this open source stuff. And Steve, you know, egotistical Steve, says to me, well, you know, I've been part of developing 2 of the world's 3 great Windows systems. Okay, and that was the Next Windows system and the Macintosh Windows system, where he was considering Microsoft Windows to be the 3rd great Windows system, at least in sales. And he said to me, and we needed a $1 billion research laboratory to do each one of those. So I don't think you're going to make it in open source. 2 years after that argument, Steve walked on stage at the Macworld show in San Francisco and introduced the Safari browser. And Safari was based on the KDE open source project. So the open source project had actually done an effort on web development that at that point Apple couldn't equal. At least they couldn't do it and have sufficient time to market. So they took the open source web browser and ported it to the Macintosh, and based upon that. And Steve stood in front of this big slide at Macworld that said, "Open source, we love it." Okay, so I won that argument, but Steve, of course, never acknowledged it. So let's consider the impact of the internet for a moment, and how the internet has actually enabled all of this community. So, say somebody proposed this 15 years ago. My friends and I, we're going to get together and write an encyclopedia. And the authors aren't going to be paid. But we'll write 3,422,000 articles, and that's just in English. Okay, I wrote that number 4 years ago. It's bigger now. Okay, we're going to kill Microsoft Encarta and Encyclopedia Britannica and all of these big venerable paper encyclopedias that have been in development for 2 centuries. We're going to kill them with our open source project. So what would most people have said to you if you had said that to them just 15 years ago? They would have thought you're just a crazy person. Okay, so imagine telling them this. 2 students' hobby projects will supplant the operating system and GUI efforts of AT&T, IBM, and the billion-dollar consortia of the massed computer manufacturers. Remember Taligent in Monterey? They were going to rewrite Unix, and Linux did not stand a chance because they were big companies with big buildings in Silicon Valley and millions of dollars, and they lost horribly. So these 2 guys, Miguel de Icaza and Linus Torvalds, their efforts, I would say they would supplant the GUI efforts of AT&T and IBM, and they'd ask, is it C++ you're using or LSD? So all of these things that, today we accept, they're really absurd. That there could be a Wikipedia viewed 15 years ago is totally crazy. So what changed? Okay, and much of the evolution of open source is filled with things that would have been thought to be impossible a few years before they happened. And this is what you call an emergent phenomenon. Nobody, with the possible exception of Richard Stallman, who was a genius, thought it would take place until it was already underway. So we should look at the factors that combine to produce this emergent phenomena and then look forward. So let's think about before and after the internet. It used to be that when strange things happened, I would hear on the radio, police believe these are the actions of an isolated crazy person. Okay? In the age of the internet, there are no isolated crazy people. Okay, whatever sort of nut job you are, there are 100 nut jobs just like you on the internet. And when you have 100 people with the same crazy idea and some spare time, you have more power to create and execute than the typical startup company. So the results for open source in Linux, we saw the rise of online communities that wanted to get something done. And the creation of this economic paradigm. Open source is a way for those people to create important projects together. And it's very different from the way that companies typically create products. So it starts with a seed And then there is a great expansion. So a motivated individual, for example, Richard Stallman in the creation of GCC and Emacs. So GCC is the compiler, Emacs is an editor. They create the tools to make the tools, okay? So we had to have a compiler before we could have all of our other software. We wanted to make it with a compiler that was itself free. So Richard developed Emacs and the compiler on a Sun workstation on proprietary software. The broader development grows from those seeds, and we get a multiplier effect as the ecosystem develops. So it starts with one person like Richard, and then it gets larger and larger. And it's happening again. So now we're in the same place that we were when Linux and free software were starting up, but for hardware. And we have another set of enabling factors. So we start with all of the enabling factors for open source software. An internet to bring us together, the economic paradigm, which we created for open source, the software tool collection, and everything that we've learned about collaboration. And then we add the transformation of hardware into software, okay? And that is, just as the internet was the enabling factor for open source, the transformation of hardware into software is the enabling factor for open hardware, on top of these other things that we had for open source. So that means that hardware is software now. A new wave of 3D printers. Okay, when I first did this talk in 2012, I actually had to explain to people what 3D printers were. Okay. They make it possible to print solid objects the way we used to print photographs, but they stink. Okay, those extrusion things, they fail the standard that we must demand of 3D printers. Okay, what is the standard that we must demand of 3D printers? They must print working Lego blocks. Okay, if they are not good enough to print working Lego blocks, they are not good enough for most mechanical things. And it's really funny, if you look at the actual mechanical standards for Lego blocks, they're really quite tight. And now we have the second generation of 3D printers, which is coming along, which is so good that you should really throw away all of your extruders if you have that first generation. And the second generation is UV lithography. So UV lithography takes a video projector or a laser, and it takes a liquid plastic and with a spot of light makes it solid, and continues doing that in an iterative process until an entire object is constructed. And this is so good that it can create moving parts inside of each other. You can create a gearbox which does not open up and which works. Okay, so I really like that. Things that were never mechanically possible otherwise. And you know, if you've ever tried to mold something, that the physics of molding dictates the shape of your object. There are things that you simply can't do in a mold, that you must come along and machine some other way, that you can do with 3D printing, that it does not have these dimensional limitations. And then we have, besides the UV lithography, we have computer-aided design systems that let us build objects to print as if we are writing software. And we have an equivalent of this for electronic design, which is the gate array. The gate array is a platform for us to create and immediately run very complex digital logic, for example, a new CPU design, without the tremendous infrastructure that was formerly needed to make an integrated circuit. So I made an integrated circuit for Pixar. And when we made that integrated circuit in the 80s, we had to design the digital logic, and we had to send it to a silicon foundry to be made. And if we made a mistake, it would take a month or two to get another version from the silicon foundry, and a very large expenditure in money. So very much of my time at Pixar back then was dedicated to checking, because it was very important that we get this project right the first time. Well, that's not the way it works today. With a gate array, you load your design into the gate array, and it becomes a working high-speed digital logic design, just as a CPU runs a computer program. But this all happens in parallel, so it is much, much faster than a CPU. So this allows us to do digital logic design that just would not have been possible for the individual before. And an individual can get into developing with a gate array for $50 US. They're very inexpensive. They plug into your USB bus. We also have something called the complex programmable logic device, which enables us to program analog and digital circuits as if they were software, and immediately run them, again, on chips that cost less than $1. And the physical complexity and the cost of glue circuits. So what's a glue circuit? When you make electronics, there are your main circuits that you're interested in, and then there's all the things that you have to do to connect one chip to another. And these things that connect one chip to another are called glue. Okay? Glue is tedious and boring, and so a CPLD chip allows us to do a lot of the glue as if it were software and get rid of some of the tedium complexity and have less parts on the board, and also be able to change it if there's a problem, which sometimes makes a hardware project recoverable when it might not be otherwise. And then the power of today's CPUs, which seems to be expanding continuously. We haven't really hit the ceiling of Moore's law where we can't make things faster. People said that we would hit it soon, back when we had 40 megahertz CPUs, and we're still doing it today. So the tremendous power of today's CPUs allows digital signal processing to replace the analog electronics of the past. And cheap, fast printing of printed circuit boards and surface mount electronics. Surface mount, if you've seen old-fashioned electronic boards, they had components like resistors and transistors, and each of these components embodied a single physical property. Okay, like a resistance is a physical property of restricting the flow of electricity. And they had this little thing that was a resistor, and it had a wire on each side, and we had a board on which we connected them with holes through it. We stuck the wires in the holes, and we soldered it with a hot metal soldering iron. We connected it with liquid metal. And we don't do it that way anymore. Instead, what's in here? Very little of those components with wires. The components in here are so small that they are hard to see without a magnifying glass. And they have no wires. They just have metallized edges. And the metallized edges are put on a printed circuit board, and then little dabs of conductive glue are put on each side of them and then melted to form molten metal. So we've tremendously miniaturized this process, And it turns out that normal human beings can actually build things this way too. They just need powerful magnifiers to do it. And so surface mounting has made a lot of electronics more compact and reduced in cost. And you can also make a design and send it away for, well, I had my first prototypes built. I had 3 boards built for, there were 700 components on the boards. This was no small thing, for about $5,000. And that was achievable for me as an individual because I have a business that can pay for that sort of thing. Whereas before, that might have required $100,000 or $1 million to do the same kind of engineering. So take what we had before, the internet, community, collaboration, licenses that gave us a way to cooperate in an intellectual property perspective. Add to that the enabling factors of open hardware, that it's now cheap and easy to make complicated electronics and physical things that we could not before. And that's how we get the open hardware revolution. So I hope that I've made it a little easier to explain to other people the economics, how this actually works and how it isn't totally crazy, and how you can use this to lower the costs in your business and to increase the degree to which you can satisfy a customer. And if you are a manager, I will send you away with one direction. And that direction is, look at everything in your business that is a business differentiator that makes you look better to your customers than the other guy. And then look at everything in your business that is not a business differentiator, that is infrastructure or enabling technology, and do not allow yourself to be seduced by not invented here syndrome. Not invented here syndrome is a disease where you believe that your company is smarter than everything else and has to make things on their own. Okay? Take all of the money that you were spending on infrastructure, that you were spending on things that were in cost centers, that you were spending on things that don't make your business better. Take all of those things and start making them through open source and open hardware collaborations. Spend less money and time on them. Take the money which you save and move that money into the development of your business differentiators so that more money of your software development budget will be spent on making your business look better than its competitors. Okay? And you will win. Thanks very much. I think we have time for a couple questions. I don't know if there's anything going on in this room afterwards, but I'm sure these people have somewhere to go. So any questions, please? Yeah, we'll give you the mic.
Firstly, more important, I believe I will be speaking for everyone here. I need to say thank you for that read here, so I can explain to them.
Oh, okay.
Okay, you can read here and it's
Okay.
here. I'm going to ask you this one. Então eu vou perguntar para ele como que a iniciativa do Elon Musk, que deixou então toda o hardware do carro elétrico e as baterias elétricas do que ele está planejando, deixou aberto então o projeto, né? E ele fez então mais ou menos o que o Santos Dumont fez, né? Ele pegou o trabalho dele e colocou aí no mercado porque ele quer ver o desenvolvimento disso. Então, por exemplo, a SpaceX não fez isso ainda, mas ele quer fazer. Como que uma ciência de fronteira como essa, se tornando aberta e livre, pode beneficiar o crescimento da ciência no geral e do movimento, né?
So in English, he was thanking me, and he was saying, well, we heard that Elon Musk for Tesla, not for SpaceX, released his patents. SpaceX runs by trade secret, and SpaceX is constrained by ITAR, the International Traffic in Arms Regulations. The United States considers rockets to be a munition, as they should, and doesn't want to give the technology to North Korea, among other people. So SpaceX cannot share quite so much as we might like. There's actually a way around that we use for AMSAT. Those same ITAR restrictions allow you to share information as long as you put it in public. Okay, so if you make something open source, you can share it internationally, but your proprietary product, as SpaceX's rocket is proprietary product, must not be given to people from Brazil or North Korea. You have to be a US citizen to work on SpaceX's technology. And I'm very sorry to put Brazil and North Korea in the same sentence. And so we have Tesla, on the other hand, that only makes automobiles. And Tesla has a problem. The problem is that there are very many automobile manufacturers, which in the case of Mercedes, I believe, have been in business for 150 years. You know, in the case of the Detroit ones, since the 1920s or 30s. And that they have very large patent portfolios that could potentially cause Tesla a lot of problems. And what Tesla actually did was not so much open sourcing, it was cross-licensing with a new wrinkle to it, which was it was cross-licensing without a signature. So Tesla's terms are here. You can use all of my patents, for GM, Chrysler, Citroën, whoever, but if you use my patents, you have to not sue me about yours. Okay? Because if you sue me about your patents, I'm going to sue you about my patents. Okay, so this is cross-licensing, and in the industry, traditionally, companies did have these cross-licenses, but they were documents that they each signed, and often not on equal terms. And Tesla, being a very small company, probably could not get equal terms with Ford, GM, Chrysler, Jeep, whatever. So Tesla instead said, I'm going to offer you my patents on equal terms. And Tesla then made some inventions in electric cars which were very innovative and tried to make it more attractive. But the fact is that Tesla has 1,000 patents and these other companies have 1,000,000. Okay, so this will not necessarily work for Tesla. We will see when the Model 3 comes out if there are lawsuits or not. And also, I think it's actually stretching a little to call it open sourcing. I think that patents are disclosed, so the source is there, and we are sharing them. But it's actually the conventional cross-licensing system that all of these companies used as long as there were patents. Next question, please. Oh, and feel free to leave if you have to. I won't get hurt feelings.
One last question. No more questions?
Yes. If you say it in Portuguese, someone will translate. Turn the power on.
Uma pergunta se vai servir mais para te fazer essa pergunta.
Nobody's making it. You said the difference between free software and open source was because it was to convince the companies. So we'd like to know what's the difference today between them, and if there is any repercussions on hardware.
Okay, so the difference of free software and open source, and what is the difference today between them, and if there are repercussions. This is a somewhat embarrassing answer. I believe that all of the differences between free software and open source that were separate from just having a marketing effort to people who weren't programmers were the result of personalities. You may know, for example, I had a fight with Eric Raymond, and Eric for some time was sort of downplaying the role of Richard Stallman in the community because he felt that businesses would be offended by Richard's very personality. You know, for leaders in this thing, this becomes a very personal thing. And so there were a lot of personalities, and we were a lot younger than today. As far as I'm aware, all of the players get along much better now. I still have a difference with Eric on gun laws, but not on free software and open source. And so I don't think the repercussions have really persisted into open hardware. I think that we have open hardware and open source hardware, and that doesn't really matter. That's just my approach to marketing versus other people's approach to marketing. I would rather use a shorter set of words, and you know, I did that purely for marketing reasons. So I think we shouldn't really concern ourselves with that, and we should be more concerned with marketing this idea to more people, first in our own communities and then among outsiders. And in that, I wish you all luck. Thank you very much.